Okay, I'm going to do this again. I made a mistake in the first attempt, and it wasn't very clear. So let's do this again. What radioactive source should be chosen for the pacemaker? Well, it would have to be alpha, because otherwise the radiation would possibly damage the person, and it wouldn't be absorbed easily. And the second point is, with this uranium, it's such a long half-life, we just wouldn't get much power from it. So that's your first answer. I'm not sure why A is there at all, but anyway, I'm just going to scroll it down a little bit for the next part. 7 grams released per second. Well, let's find out the activity first. That's going to be lambda n. Now, lambda is ln2 divided by the half-life, which we said was 88 years. So let's get that into seconds. So just working that out. And that gives me 2.1, 2.20 times 10 to the minus 8. No, that's okay. Yeah, 10 to the minus 8 per second. And the number of nuclei, well, we know 7 grams. 7 grams, that's 6 times 10 to the 23 nuclei. A mole. Sorry, no, it's plutonium-238. So sorry, 238 grams. Would be 6 times 10 to the 23 nuclei. We want 7 grams. So I'm going to do 6 times 10 to the 23 divided by 238 times 7. And that gives me 1.76 times 10 to the 22 nuclei. Combine those two to get the activity. And that gives me 3.88 times 10 to the 14. Now, each activity releases 2.5 mega electron volts. I'm going to convert that into joules by multiplying by 1.6 times 10 to the minus 19. So that's 4 times 10 to the minus 13 joules. So now if I multiply that by 4 times 10 to the minus 13, that should give me the power or the energy released per second. And that is, oh gosh, what have I done? Have I made another mistake? 3.88 times 10 to the 14 times 4 times 10 to the minus 13. Okay, so this was my original mistake. There was a mistake here. That was 2.50 times 10 to the minus 10. And that will give me a different activity, yeah. So I'll multiply that by my nuclei, 1.76 times 10 to the 22. So I get an activity of 4.39 times 10 to the 12. And then I multiply that by 4 times 10 to the minus 13, and that gives me a power of 1.76 watts.